The human brain can identify images correctly seen for as little as 100 milliseconds. That is roughly the time span of the blink of an eye. Newer research from MIT even suggests that we can identify images after seeing them for only 13 milliseconds. So our brain is obviously highly optimized towards image processing. But still, oftentimes, we don't seem to leverage this feature of our brain and use it to our advantage. At least this is my experience in working with data for a long time in various roles like digital analyst, BI manager, software developer. So somehow I feel there's a gap in education also, because I managed to get a degree in journalism and corporate communication, but never learn about communicating data, or a degree in computer science for media applications, but never learn about, analyzing the data visually that we create with our apps, or how to show data in our apps to the users effectively. So today I want to use this opportunity to draw your attention to this topic that has so much potential and might make you more successful when analyzing data, but also when communicating data to others. But I think a quick introduction is in order. My name is Sophie, and I work at Backend. Quite some Backend colleagues here. Hi, thank you for joining. And thank you all for joining. I'm super happy that so many people are interested. So at Backend, we have a product called SpeedKit, and in the product and customer insights team, we are analyzing the data that this product creates. And with SpeedKit, we optimize the page load times of more than 7,000 websites, more than 10,000 websites even, I think. And that means that we That means that we optimize the user experience of more than 100 million or even more users every month, monthly users. And of course, we are quite busy with analyzing this data, and we need to use data visualization in order to, even leverage it. However, my talk is not about backend today. But it could be, because there's a lot of interesting things to say. Luckily, our co-founder and CEO, Felix, will give a talk later today, and he will give some insights on how we scaled our analytics stack from basically 1 to more than 100 million monthly users within a month. It's a quite interesting story, so you might want to check this out. What I also do besides working at Backend and obviously preparing topics about data visualization is doing some fun little research projects in the field of creative data visualizations, especially interactive browser-based and 3D visualizations. But I will show you some examples for that at the end of the talk. And I will also show you some even cooler work of a few creative digital agencies and artists doing really cool data and machine learning art. But before we go to that, we should really cover the basics. So I want to give you now a few hands-on tips how you can visualize your data more effectively. Actually, I have 3 takeaways for that. And then I will also give you a little inspiration on how you can communicate data more effectively by applying some really simple storytelling methods. And there will also be 3 tips. But before we start with that, maybe you want to, get a little understanding of why this makes sense. So when we summarize our data, that leads to a loss of information. If you calculate summary statistics, basic scores, KPIs whatsoever, and that's the point of it. So don't get me wrong, I'm not saying you shouldn't summarize your data. Clearly you should, because it makes sense for many reasons, reducing complexity, enabling us to compare data sets, and so on. However, what I am saying is that you should also visualize your data and leverage this power of your brain that can provide additional insights that the data summary doesn't provide. And if you don't believe me, I have a quick example for this. So here we are looking at 2 data sets. At least I say those are 2 different data sets because we're actually only looking at the summary statistics, and if you look closely, you might realize they are the same. Now, we could conclude that those data sets are somewhat similar. We could think maybe they are even the same. And if we now visualize it, we come to a very different conclusion. So if you would have skipped the data visualization part, you would have missed the dinosaurs. So I please ask you to also visualize your data and don't miss the dinosaur in your data. And also kudos to the research team behind this project. It's really cool. There are actually 12 images with the same statistics, very different shapes. And the data set is called, I think, the Datasaurus Dozen. It's really a cool project. However, we want to continue now with the question of how can data viz make us more effective in communicating data. And my point here is that it has been proven by science that when we learn information, it is easier for us to learn it if it is provided both verbally and visually combined instead of just verbally. So I think this is a very clear point for data visualization, because all of us working in tech somewhat pretty much have to talk about data in some sense at some point. And if there's a really important decision you want to support based on data, for example, in a pitch presentation or in your next retrospective meeting or in a budget planning, then I would suggest to use this fact to your advantage. Now you might think, okay, I get it, I will visualize my data, but how hard can it be that we need to spend another 20 plus minutes on talking about it? And I wouldn't blame you, because I have been at that point, at least, until I started to dig deeper into the topic and realized that intuitively the charts I created weren't as effective as they could be. And actually, now in retrospective, I realize I created my fair share of pretty bad charts, to be honest. Actually, I could talk probably 30 minutes about bad charts and showing you examples of, ineffective at best data visualizations, or in the worst case of even misleading or lying data visualizations. In this case, you see that 22 is not even half of 30. I think it's not quite correct. But I decided not to go down this route, even though it would be amusing. But I want to be more constructive and give you, some tangible takeaways today, how we can all do better and be more successful by using data visualization. So if you're interested in seeing more of those kind of examples, please visit vis.wtf after the talks today, or later, on your way home, not now, please. And it's basically a collection of data viz gone wrong. It's quite amusing, but also, you can learn pretty much from it, I think. So with that being said, I finally start with my 3 tips for more effective data visualizations. So now I do. My tip number 1 is default to bar chart. Set your default to bar chart. So when we visualize quantitative data, there are several options how we can encode it. We can use color in a heat map, we can use angle, or we can use area, or we can combine both of those channels by creating a pie chart. And we can also use length or position in a scatter plot, for example, or we can combine it like here in a aligned bar chart. And now this might not come as a surprise. Science, again, has found that not all of those options are equally effective. That means that our brain is most accurate decoding the information if we use length or position. So position is even the most effective channel. So a scatter plot, for example, is really nice. But in my experience, in the daily work we have, the use cases for a bar chart are most common. And also, I've seen so many charts that should have been a bar chart that I think it is a good default. Especially you should pick a bar chart over a pie chart unless there is a functional reason why it needs to be a pie chart or why it needs to be a heat map. So I'm not saying that this is the wrong choice, so please don't get me wrong. That are good charts and they have their use cases. But if you're not sure, and if it can also be a bar chart and effectively transport your message, then go with that. Now, the second tip is to drop color if you can. And there are many reasons for that could also fill another talk, but I decided to focus on a few arguments that, again, save our brain some bandwidth. And now if you look at this example, if you want to decode the information in this chart, you would have to switch back and forth between the color legend and the actual encoding of the data. And you have to remember the mapping of the color and the category on the way. So this is quite some active work you have to do. If you would instead, for example, label the segments directly, you would drop the color legend. You can also, by the way, reduce the color a little bit by, for example, using gray, but that's not the point. The point is that at least dropping the color legend makes it already easier for your brain. But there's also a good example to drop color completely, like in this case. And you might think, this is not a typical chart, but I have seen this quite a lot, actually. So it's a bar chart that uses color even though it has no meaning. And that is pretty much so distracting for the brain and not giving any benefit that is highly ineffective. So if you just drop the color, your brain will be able to focus on actually seeing the data. And it will not wander around, try to make sense of the color, try to find some kind of legend that maybe gives it some additional information. So all of this, additional work you can skip, because in this case, it doesn't even give you any benefit. Now to my third tip, and my favorite tip probably, is declutter your chart. And you can also say remove the chart junk. That's a common term in the data viz community. So there are elements in this chart that do not transport any information. The same like I just talked about the color that didn't convey any really additional information or insight. And then also we can arrange this chart in a way that is a little bit clearer to look at and easier to interpret. So I know that sounds a little bit vague, so I would like to give you a step-by-step run-through and see how we can optimize it by just copy-pasting it and step-by-step removing some stuff. So what I will remove as a first thing is the colored background, which to me doesn't really make sense. It reduces the contrast that the data has to the background, so it defocuses basically the pattern. Then we can also drop the border because I mean, why do we need a border? I really don't get it, why this is default so often. And then there's already a way clearer picture on the data itself, and it's not so much distraction around it. Now what we can also do is remove the grid lines. This is not something that I would usually tell you to do, because it very much depends on the case, but here we have labels at the bar, so we can see the values, and it's not really that necessary for us to have a second option to read the values. And why would we do the effort of going to the axis and try to decode it there if it's already labeled? So you can, of course, also, for example, drop the labels and keep the grid. Also be fine. I went with this option. Now there are even more redundant things here, and these are the labels at the axis. So we have the titles at the axis, and we already have the chart title telling us what we're looking at. So it's very redundant, and it is unnecessary attention that is used in order to read those redundant information. And also it's clutter around, so it defocuses from looking at the data. Another thing we can remove are the decimal numbers here. And also I removed the numbers up. That's a question of taste for my case here, but I think it's easier to read, and you can, the data stands for itself. However, important really for me is the decimal numbers, because in this scenario here, they didn't convey any really important information. Of course, we lose information by that, but the question is, do we really lose insight? So how relevant are those decimal numbers to the message that you're now trying to convey, the insight you're trying to gain? And the last thing we want to drop is the high contrast of the labels, actually. So just tone it down a little, not too much. It should be, readable. But if your labels in the chart have very high contrast, this is something that your eye is automatically drawn to. So our eye is just focused on contrast by default or automatically. And if you tone it down a little, then the data stands even out a little bit more. Now we are done with the dropping, and now we want to rearrange this chart. And I will do this in one step and just walk you through what I did. So the first thing, and this is something that I have learned also quite late, and now I do it all the time, is to turn it into a horizontal bar chart. If you have long labels, and if it's not really necessary that it's not a timeline, for example, then using a horizontal bar chart instead makes total sense, because it is our natural reading habit, to read from the upper left to the lower right. And this is so natural that for me, it is way easier to get information out here. And also, I sorted the bars by value. So the highest value is up and the lowest is at the bottom. And now if I look at this chart, I don't even need to compare the single bars to, get the information of which one has the highest or the lowest values. I can just read it. It's a ranked list, and through looking at the whole chart pattern, I can detect that and get insight without even doing much work. So I am now happy with the version we got here, so I will move on. Of course, like I said, this is all very case dependent, but those are some steps that very often are applicable, so maybe you think of this when you create your next visualization. And with that, I am done with my 3 tips for more effective data viz. And I told you there will be 3 more tips. Don't worry, they will be quicker. And after that, I will just show you one quick example how it is applied, and then we are already done with the heavy lifting. So my first tip for communicating data effectively is to use something called the pop-out effect. Science has found that there are certain visual elements that automatically, again, focus our brain's attention, let's say. So color is one of them. If you highlight one element by color in an otherwise calm, uncluttered environment, then this element will automatically pop out, and your brain will automatically look at this one element. I mean, you get the concept of text markers and so on. It's basically this. And now, that you have your audience's attention and focused on the right thing in the data, you can also add annotation in order to give more background information. So let's say there's some outlier you want to explain, or there is, I don't know, a point in time you want to highlight because something relevant happened that changes the shape of your data from there. And if you have applied this step, then you can finally add a directive title. And by that, I mean a title that basically summarizes the idea in the data, the idea in the chart, the message you're trying to communicate. So not just say maybe metric A by category, but give a really good summary of what you want them to take away. Basically a takeaway maybe. You can even add an action point or additional context information if needed. But I think a summary of your main point is really important here. And now you might think, but isn't this kind of redundant? And didn't I just told you to drop all the redundancy from your chart? And to that I say, yes, it is totally redundant. But maybe you remember from the beginning of the talk where I said that learning information is easier for us if provided both visually and verbally combined. And this is what we are leveraging here. So it is redundant, but in a visual and verbal channel, so it is actually more effective. And I have now one real-life example to not only show you the dummy charts. This is something we recently worked on for a blog post. My colleague Erik did an analysis on different tracking strategies. You don't have to get the whole context of the data in total. Just maybe a quick summary. So there are different different strategies or approaches you can use to track certain information. And they are not all equally reliable. So meaning in some cases we lose the information because it doesn't work, the tracking doesn't hand us the data in time. And Eric analyzed the data and found that there's this new approach by Google that is actually performing way better than traditional methods. So traditional methods only reach 90% of reliability. And this is what we wanted to highlight here with the annotation. And then we also wanted to highlight with the pop-out the new strategy that my colleague tested here that actually gives us a much better reliability. So it's the best result, but also the new kid on the block, which is why we wanted to highlight it. And then we have the directive title here. And this is basically, like I said, just summarizing what the chart is already telling, but then also giving this additional information that this new approach is currently still in origin trial. So it's a test phase, basically, and cannot yet be used everywhere. But, it is something that you should look out for in the future. And this is from a blog post that my colleague published on our company blog, where you can find it, and we even included 4 of those, visual takeaway summaries, because there were like 4 very interesting key findings that he made during his benchmark analysis, and we wanted to share this with the community. So if you're interested in either the performance of different unload strategies or just want to look out for some data storytelling examples, there are, different elements. We use different kinds of highlights, but basically pretty much the 3 methods I just showed you. And what you could, by the way, also do, and this is like a very strong recommendation, is after this talk, just stay in your seats and listen to the next talk from Wolle, who is already here. And by accident, that's really a coincidence, he will, in his talk, also address this benchmark analysis. And he will share plenty of much more wisdom, so I can highly recommend to stay here. Exactly. So, but now, enough with the advertisement and enough with the tips and enough with the bar charts, I promise. You have now made it through the heavy lifting, through the hard part, and if you have some nachos or popcorn left, I can say lean back, enjoy. I will show you now some colorful images, and yes, you heard correctly, there will be plenty of color from here on. And I would just want to, show you some more advanced and then also more artistic ways of visualizing data that hopefully inspires you, because some of you might really have some interesting use cases for this, because not everything fits into a bar chart, right? Talking about this, I want to start with the idea of visualizing network data. Is anyone here who visualized network data at some point? Interesting. I would like to hear your experiences later. Nice. So network data. This is an example from Cambridge Intelligence, not to be confused with Cambridge Analytica, completely different company. What they do is visualizing networks. So that is their business. And the use cases are, just to name maybe here, fraud detection, for example. And this image I picked is a visualization of an IT infrastructure. So there can be interesting use cases. This is not like everyday business, but be open to the idea that it can be maybe helpful for your specific problem you want to solve for your specific data structure. Another area is high-dimensional data, and probably some of you are dealing with this kind of topic or data structure at some point. And if you haven't heard of it, there's this technology called t-SNE. I hope I'm saying this correctly, probably not, but I tried. So it's basically applying machine learning statistical methods to reduce the dimensions in the data. So it is basically dimensionality reduction in order to create a visual summary of a data set that has actually very, very many dimensions. And this example is from a research paper. I picked it actually quite randomly because I just liked it and liked the look. But if you look for this on the internet, you will find many different applications for this. And then there's also geospatial data. And this is, like I said, again, a very specific use case. But if you have like a lot of geospatial data at hand, or you have some use cases where you're dealing with geospatial visualizations, there are plenty of things you can do. It's a very, wide field and very specific challenges, I think. I'm not into that yet. I haven't had so many use cases for it, so I don't have so much experience to share here, but I want to highlight the work from Craig Taylor. He's a data viz designer and artist also, and he shares some very cool data viz projects where he visualizes geospatial data and even does it in a very, I would say, artistic way. And this is a really good segue to my next topic, which is, and probably also last, data and machine learning driven artworks and sculptures. So far, we have been focused a lot on how data can make us more, effective and efficient, and how we can solve our business problems with it. But there's also this area which I care about a lot, of appreciating the art of data and, just admiring its beauty, playing around, being inspired by it, and looking at it from different angles. And this is an area, and this is a very tiny, glimpse into this whole field. There are so much things happening. Here are some examples from Variable.io. It's a studio. They create this kind of data-driven artworks for companies like Google, IBM, Twitter, and they have really interesting, cool projects on their website. So it's just a, example that inspires me a lot. And then there's also one of my, or probably currently my favorite artist, Rifik Anadol. He does machine learning art, I would say. He also talks about it as machine hallucinations. This is a screenshot from his website because I couldn't pick one example, and one example wouldn't, communicate or show how rich his work is. And even this screenshot is not a good example, probably anyways. If you haven't, seen his work or heard of him, I just can recommend to checking his art. It's really cool. Currently, he has a project exhibited at the Museum of Modern Art in New York even. And I think it's interesting to see that machine learning and huge data can also be applied in this area of science, of art, and not just, in the business context, for example. And I'm happy to see that other people also care about looking at data in the form of something beautiful. So I think it's really a really nice and interesting field to follow. And when looking at those images, I actually also get a little bit sad, because even though I appreciate looking at the images, I never really can interact with those the artworks live. I can only, see the images and videos of it, but oftentimes they are somewhere shown, exhibited in a very, special setting, location, for example, in New York in a museum, or this Vegas bulb thingy. I'm not sure if you know what I mean. There, some of the work from Rifik Anadol is currently also shown, for example, and you have to fly over there to see it live and really experience it live the way the artist has meant it. And that is often not really possible for me, or it's shown at some, company meetings and so on. So that inspired me to research a little bit on my own to create some kind of interactive 3D browser-based data sculptures. And this is just some examples and super very early on experimental stage. But I think it's interesting to see if we could create something like this in the browser and share it, be able to share it with everybody and let people interact with those data sculptures, but then maybe also give them context on the data that is used. So it can be also very good combined to let people just enjoy the beauty, but also, if they want, give them additional information. And yeah, that's what I'm researching, but actually there's not really a community for this niche. So at least I didn't found one yet. So it's mixing technologies from the data visualization space like D3.js, but also gaming technologies like 3.js for this 3D visualization or Canon.js for gravity and stuff. But it's either data with people or gaming people, and I didn't find so many people who are interested in this mix of both. If any of you are interested, feel free to, reach out directly after the talk or later somewhere at some of those channels. I would be really happy to chat about it and, exchange ideas. And with that, I am done, I think. I hope I didn't forget anything important. I, again, want to thank you for coming. I'm really happy to see so many people interested in this topic, and I really hope that you could learn something today. And I don't have so much overtime. It's good. Now that I do have some minutes, I can just to see a summary of my 6 tips. I'm not talking about it. I just want to show you so you can, take it away better or remember, because I heard that this helps learning information. I'm open for questions.